And yeah, today we have with us Samantha. She's a PhD student in HCI at CMU and a research fellow at NASA Space Technology Research. Samantha received her Bachelor in Arts in Information Science from Cornell University and a Master's in HCI at CMU. Samantha studies how robots communicate with people. She is especially interested in investigating this interaction when robots need to interact with multiple people and when they can have multiple physical embodiments and identities. And what I like so much about Samantha's work is that she combines research through design and methods from social sciences to study social robotics. I'm very much looking forward to this talk, and I invite Samantha to take in the stage now.
Thank you so much. Okay, I think my screen is up and running. Yes? Excellent. So, thank you for the wonderful introduction. I'm Sam Reig. I am a PhD student at Carnegie Mellon University in the Human-Computer Interaction Institute. I'm really excited to be here on Talking Robotics after having attended a lot of your sessions and listening into some of the awesome discussion that goes on afterwards. So thanks for having me. So this talk is characterizing agent identities as mediators among individuals, embodiments, and services. And this is an overview of a bunch of work that I've done with my co-advisors, Jodi, Forlizzi, and Steinfeld at CMU, as well with my fellowship mentor, Fong, over at NASA Ames. And I'd also like to give a shout out to Jeff Kaufman, my other thesis committee member, who has been a wonderful mentor in the presentation of some of this work. So we're going to be talking about, of course, individuals, embodiments, services, and agents. So that's a really complex set of things. And because of that, I'm going to start with a scenario. So imagine that there is an astronaut working with an AI in training for a mission. And over the course of several months, that AI learns about the astronaut's professional and personal history, her area of expertise, her strengths and her weaknesses within that area of expertise, her health needs, her family, her personality, her communication style, and so on and so forth. And when she's ready to begin her extraterrestrial mission, that AI embodies the robot who will collaborate with her on the task. Now, because she's working with a familiar agent, although it's in a totally different robotic body in a totally different context, she can make use of her knowledge and her impressions of what the robot has already learned about her from their prior interactions. And maybe she can be more confident about what the robot knows and what it doesn't know, including its understanding of her own knowledge and her own expertise. Maybe she can feel more comfortable with the style of communication that it uses, and trust the robot to correctly interpret her words and actions, all because of the fact that it's presenting itself to her in a way that suggests that it has and understands a history of prior interactions with her. So it's both the fact that it actually has this history and the fact that it presents itself as having this history that are impacting her interactions here. Slightly different scenario, which might be more relatable for those of you who have not been to space. Imagine that you're getting ready to travel to a place that you haven't been to before, and you give your itinerary and your packing list to your personal agent before you get ready to go. And then when you get to your destination, you stop by a local grocery store, and your agent embodies the store's robot. And in doing so, it draws on all of the knowledge that it has about your packing list and your itinerary and your history to help you navigate through this store you've never been to find the essentials that you need for the first few days of your trip, but that you don't already have with you. So both of these contexts are, of course, pretty complex. They don't assume that human-robot interactions are one-to-one. So a lot of research that we do and see in HRI focuses on one-to-one contexts, or maybe focuses on the fact that a lot of interactions are situated in a broader context, but actually experiments with one-to-one interactions within those contexts. Of course, the two scenarios I described are socially complex, not one-to-one. So in the space scenario, there are other astronauts on board. They all have their own skills, their own habits, maybe their own agents, just like the astronaut that we were focusing on. In the grocery store, you've just gotten to this store after traveling to a foreign place, and you're interacting with your agent and this unfamiliar robot, and you're surrounded by strangers, probably because they're also shopping. So that's a socially complex situation. And maybe if you were back home, you'd actually be bumping into people you know. So these are things that we can consider when we're looking at how to design the way social robots interface in services. Similarly, there's sometimes an assumption that human agent interactions involve just one agent that embodies just one robot. And obviously these scenarios do not have that as their design. The reality is that human agent interactions can be technically complex, involving multiple embodiments, multiple subsystems, and multiple tasks, both now and in the future. So in the space station situation, that AI was interacting with that astronaut surrounded by all of these consoles and maybe multiple flying robots, maybe multiple microscopes. And there are a lot of different tasks going on all at once. And of course, like I mentioned, different astronauts. In the supermarket, you have information kiosks, checkout registers, other robots roving other aisles. And there's no reason to really assume that a certain design for how all of these various embodiments should interface with people would be the one to go with. So maybe instead of having each of these systems have its own identity or its own agent, we consider them as sort of one overarching system that has a single identity, or whether we design it to have an identity or not is actually focusing at the level of the whole supermarket and not at the level of the individual robots and interfaces within it. So this has raised a lot of questions about how we can design these systems that behave socially and how decisions about their design and implementation can impact social and behavioral outcomes in HAI. So for example, should we design for one agent or multiple agents? Should we design agents to be tools or peers or collaborators or something else? And when do we even have influence over the mental models that people form? When and why does it even matter? So agent identities are something that sit at the center of these questions and at the center of these relationships among people, embodiments, and services. And we look at how they can mediate interactions and perceptions in those relationships. So we have agent identities and individuals. Among other things, agents can affiliate with individuals. So say I have my Siri that I consider to be mine because it's on my phone and has my data, and you have your Alexa that you definitely don't consider to be mine because that's your Amazon data. In return, individuals attribute social qualities to and can form mental models of agents. So maybe you see your Siri on your phone as a useful tool, or maybe you see it as an intrusive nuisance that tries to be a social player but just utterly fails. Agents can also interact with embodiments. So when an agent embodies a piece of hardware or a robot, whatever hardware capabilities that embodiment has constrain what the agent can do and how much strength and what kind of an identity signal it can perform. So if you imagine an agent interacting through a smart speaker, it can't interact gesturally because that speaker is limited to just voice interaction. But if that same agent goes and embodies an actuated robot, like the grocery store example from earlier, it could now theoretically use things like gestures and movements to give new cues for its identity and cause people to project additional social qualities to it. So one thing we look at is how that movement can project impressions and perceptions from one embodiment to another. So again, we're really focusing on, because of the complexity of these scenarios, we're focusing on not just the two-way relationships between, say, agents and individuals and agents and embodiments, but how all of these things play together. So this arrow that I just put on the screen, that looks at connections between this sort of three-way relationship. We also talked about services. So services can provide data to agent identities and prescribe their actions and their behaviors. And in this way, agent identities can come to serve as service touch points. So you might consider Alexa to be a service touch point for all of Amazon, or if you ever had a customer service chat with a chatbot that's gone either really well or really poorly, that interaction has probably shaped your impression of the service. And when we bring multiple people into the mix here, issues of how agents can influence service perceptions become more complex, because now if you imagine something like a poorly timed notification from Alexa where you've just ordered a gift for your friend who's in your house right now and it's a surprise, and Alexa mentions that such and such a delivery has arrived, that might totally change the way you perceive it as being competent or not, and the way you perceive Amazon, because it hasn't taken into account the fact that it's actually fitting into a social context, which might have other variables like other people around listening to what it says. So in our work, we again are trying to better understand these arrows, these three-way relationships. And we ask the question, what can we as researchers and designers of agent identities do to better predict how agent behaviors will shape interactions among individuals, embodiments, and services? And you heard earlier that we use sort of a combination of methods inspired by social psychology and methods inspired by research through design to attack this. And that's because sometimes we have sort of inclinations or predictions that we get from prior work, either the large body of work on group interactions in HRI, or work on how embodiment impacts interactions. And we can use that to form specific hypotheses that we want to test. And so we use more controlled studies. Other times we're projecting into this future set of interactions that we don't yet have and haven't scoped and haven't yet actually designed. So therefore we use more exploratory research through design methods where we're prototyping and we're really trying to ask questions to understand desires and values. So you'll hear both of those. So the first sort of mediating role that agents play in these complex environments in our work is as touch points for services. And the first two studies that I'm going to talk about look at interactions between individuals and services, and also between multiple individuals in the context of services. In these two studies, we were interested to learn about two possible future behaviors of agent identities that act as service touchpoints. First, personalization, and second, re-embodiment, which is the notion of the same identity moving from one physical body to another. Both of those ideas were mentioned in the scenarios from before, and here we explored how people would react to them. So we conducted a user enactment study on this concept. And user enactments is a method that was developed in part by Jodi Forlizzi and John Zimmerman, and it involves using low fidelity prototypes and Wizard of Oz methodology to give people an opportunity to get immersed in several possible futures involving designs and systems that don't actually exist yet. People interact with these mock-ups and these prototypes and these narratives that we give them. And in doing so, they can critically reflect on what they saw and what they did and what they felt. And they can compare their experiences to each other, and they can sort of understand what they value and find appropriate and desirable and tell us that information. And that gives us an opportunity to understand what it is we should be designing for. So here we explored 3 service contexts. We looked at a hotel concierge where we asked participants to imagine that they were figuring out where to get dinner with the help of an agent. We looked at a doctor's office lobby where we asked people to imagine they were checking in for a flu shot, and that the check-in person here was an agent that embodied a robot. And then we looked at a department store context where we had people imagine that they were shopping for something that they need. And to really dig into this idea of multiple individuals and these social privacy concerns and social dynamics concerns, we had people come into the lab in pairs. And we asked people to imagine that their study partner was their friend from work, which was sort of a deliberately vague relationship. You could have a close friend from work, you could have just an acquaintance, you could have a professional contact, and that's why we did that. We also explored 3 agent configurations. The first one was a singular agent, and this is sort of your one-to-one model or the human model of how an agent and an embodiment might behave. So a single service agent, a single robot interacting with everyone in the space. We had personal service agents where we had 2 service agents, 1 robot, and each agent interacting with particular people. So the story here was that each of these friends from work would have had someone who was affiliated with the service, who had a prior history with them, but it wasn't the same someone, so therefore 2 different agents co-embodying the same robot. Finally, we looked at the concept of life agents, and this was the design that most closely mimicked what I described earlier about the astronaut who goes to space with her personal agent, or you going to the grocery store with your personal agent. These agents were designed to present themselves as though they had a personal history with the user and not necessarily with the service. So these were the kinds of agents that would, say, follow people from place to place. And we communicated that by having them draw on information that could not possibly have been obtained within that context. So it came from, say, the user's home or the user's interactions with a different service. So those were the really personal agents. So through this study, this one, we started to get a sense of sort of the high-level pros and cons of personalization and re-embodiment in various contexts. And we followed up on that with an online study that used speed dating with storyboards to look at several contexts in which robots might re-embody to personalize their interactions. So I'm sort of holding off on the results from the one I just described so that I can explain how both of these together complemented each other and gave us a larger set of results later on. And in this study, instead of exposing people to in-depth, physically enacted in-person theatrical stories with future prototypes, we used a much lower fidelity, simpler method of designing storyboards. But the flip side of this is that people can quickly cycle through a lot of different storyboards and see a broad set of designs and therefore make a lot more comparisons. So these two studies complemented each other nicely in this way. You can read more about both of those methods and also in more detail about those studies in our HRI 2020 paper for the first one and our DIS 2021 paper for the second one. So across these two studies, we've learned that personal conversational agents that embody public robots can afford HRI that aligns with users' values and meshes with their preferences for social interaction. So one participant said that they wanted a robot or an agent to be sarcastic because that's how they are. And that was something that they found to be particularly possible and valuable with the life agent, so the really personal one. This person also was pretty focused on the idea of having agents and robots in service contexts behave socially to begin with and have conversations and communicate that they understand social norms. Some other participants in our studies really wanted agents and robots to just be tools. So something else that this ability to mesh with users' values or say align with their preferences and be customizable speaks to is this difference in how people even want their agents to behave, whether they want robots to have identities or not. And yes, somebody else mentioned a calm, cool, and collected person to be able to have a matching robot. We also learned that personal conversational agents that embody public robots can afford HRI that's sensitive to individual people's needs and provides emotional support. So for example, a lot of this feedback came from the doctor's office context in both of our studies, where some people mentioned that they were afraid of needles or anxious in medical settings, or that they knew other people who were, and that therefore an agent who follows you from place to place could read that about you and respond in a way that's comforting. And that the familiarity alone could also be comforting. So someone said, if you're feeling anxious, it's nice to have that agent along with you who knows everything about you. Of course, there are also downsides that people pointed out to these designs. One of them is that comfort with agents personalizing and re-embodying behaviors can depend on people's confidence that the agent can actually have expertise across multiple domains and that it actually can multitask. So someone mentioned we tend to associate low expertise jobs with a lack of competency in high expertise jobs, and that can make someone feel less confident. And we weren't really sure whether people would point this out with agents because a lot of people who come participate in our studies sort of know that AI is not limited by the same memory constraints and the same processing constraints that people are. And so we thought maybe they would think that a multitasking agent could do anything and everything. But we actually found that a lot of people said that just the perception of it doing many different tasks in many different domains might decrease their confidence and their trust. Somebody else said if they can't focus on their job and gets mixed up, that could be disastrous. And finally, comfort with agents personalizing and re-embodying behaviors depended on the surrounding social context and signals that the agents and robots were aware of it. So somebody said, how did that agent know that we were even okay with getting recognized in each other's presence? Someone else said, if we feel comfortable enough as coworkers to go to the clinic together, then I think we can share the same robot body. The inverse of that being presumably that if they weren't necessarily comfortable with each other as coworkers, then they would want to go to the health clinic and have individual embodiments interacting with each of them. They wouldn't even want to have to think about whether there was maybe data being shared or maybe something that would be said aloud that shouldn't be said in front of just an acquaintance. So to summarize, we've learned that customizable identities can align with users' values and preferences, that they can provide emotional support, but also that multitasking agents might not be trusted to be experts in everything, and that agents need to consider the surrounding social context. So we've now learned some things about this right half of this agent identities, people embodiment services framework. Now we're going to move on to the other side and look at agents that affect perceptions of multiple embodiments. There are a lot of reasons why an agent identity might serve to mediate between people and multiple robotic embodiments. One of them is, if you imagine that an embodiment, such as one of the robot arms in the space station or one of the aisle roving robots in the grocery store, if one embodiment fails and the system needs to explain itself to the user and respond to that failure without fully functioning physically, without having all of its components working as they should be. So in this part of our research, we're looking at multiple individuals sometimes, and we're looking at services peripherally, but we're really focusing on how perceptions of an agent identity in one embodiment might project to additional embodiments that are part of the same system. So to look at failure, we ran 2 online studies that looked at 4 possible ways that agent identities might recover from failures in multi-robot systems. And here we played again with the idea of disentangling a robot's intelligence from its body. So each of the various study conditions had either 1 or 2 robots and either 1 or 2 intelligences. The first strategy was, again, this one-to-one model or the default model with a single identity and a single robot.
An error has occurred. Let me update my software. I will not experience the same error again.
So in that video, a robot dropped a package on the bottom of a ramp. It said, an error has occurred, let me update my software. Then it moved around, did a little dance and said, I won't experience the same error again. Then we had 2 conditions that involved 2 robots and 2 intelligences. Here's one of them.
An error has occurred. Let me call another robot. I will not experience the same error as the previous robot.
So in that video, the robot again dropped the package. Then it said, let me call another robot. And then a second robot with different eyes came in and said, I won't experience the same error as the previous robot. We had 2 conditions that looked like this. This one was call, the other one was sense. And in sense, the second robot basically did the same thing, but it just sensed the failure and came in and proactively said, I'm going to take over from here. Finally, we had the re-embody condition.
An error has occurred. Let me move my brain over to a better robot body. The problem is fixed. In this robot body, I will not experience the same error again.
So this one looked pretty similar to the previous one, but the robot dropped the package. It said, let me move my brain over to a better robot body. Then the first robot's eyes went dark and a second robot came in and it said, in this robot body, I will not experience the same error again. So we're looking at pretty simple verbal and visual cues here to connote the intelligence moving from body to body. So we ran these 4 conditions as a within subject study. We randomized the order. So we had 130 participants able to see all 4 videos. They also saw a baseline video at the beginning where the robot didn't fail. And in doing this, we predicted that competence and trust would be highest when a robot recovered on its own. But we weren't sure if re-embodiment would be perceived more like a robot recovering on its own or more like a 2-robot recovery. So we were looking at that. We also predicted that a failure that was recovered with a re-embody recovery would be perceived as a hardware problem, whereas a failure that was recovered with a second robot could be seen as either a hardware problem or a software problem. I'll note here that this is a summary of a longer set of hypotheses that has some of this broken down more specifically. And if you're curious about that, you can take a look at our HRI 2021 paper, but I'm just summarizing them here for the sake of simplicity. So we did find that for trust, for the update recovery, trust was highest. It was significantly higher than it was for all other recoveries. And in fact, it was similar to how it was for the baseline condition where there wasn't a failure at all. And update was closely followed by re-embody, which scored significantly higher on our trust measure than sense, but not significantly higher than call. For competence, it was a similar story. Update and re-embody were both significantly higher than call and sense, and they were also perceived similarly to each other on competence. We also asked people about what they preferred, since they did get to see all 4 strategies, and they overwhelmingly preferred the update recovery. They also overwhelmingly ranked sense as their least favorite recovery. Re-embody was the second most preferred, but also the second least preferred, so people seem to have mixed feelings about that. So it was true here that competence and trust were highest when the robot recovered on its own. The re-embody recovery seemed to fall somewhere in between a single robot recovery and the 2 robot recoveries. So for trust and competence, it wasn't as good as update, but it was better than call and sense. Re-embody failures were also perceived as hardware problems far more often than the other conditions were. So one person said that a failure was from a hardware issue when the robot updated its software. 23 people said so when a second robot sensed the failure. 13 people said so when a second robot sensed the failure, 23 when the first robot called the second robot in, and 66 said it was a hardware problem when it re-embodied. So what we saw here was that participants rooted for an identity that had failed, and also that individual differences played a role in people's preferences and perceptions about the different strategies. So what I want to highlight in broadening the lens back out to this map of agent identities as mediators, which I'm about to do, is that first, a resilient identity can mitigate effects of failure on trust and improve perceived competence. And second, this study showed some empirical evidence that attributions to identity don't necessarily equal attributions to embodiment. Also, both of these concepts are things that have been looked at in more detail in research that's happened since we published this paper. So if you're curious to see how people might use more in-depth cues that are possibly more complicated than just a verbal, the robot telling the user that it's moved its body, and also see different robots in different contexts with some of these findings coming into play, you can take a look at these other papers. So what we have left in this map is this space between individuals and embodiments, but focusing more on individuals. The last one focused more on embodiments. So the last study that I'm going to talk about focused on agent identities as mediators in human interactions. And in particular, we looked at the concept of an absent individual and an agent interacting with an ancillary user. So in this study, we wanted to understand how people might interact with agents that are not theirs. We were curious about how perceptions of complex social constructs like intent and loyalty might manifest when an ancillary user gets either bad or good information from an agent that's known to primarily interact with somebody else. So here we were looking at, in terms of intent, big questions like, why is the agent willing to give me information about someone else's private space? Is this something that would even come to people's mind when they're interacting with someone else's agent? Why is it misdirecting me? Is it acting on behalf of its primary user, or is it acting on behalf of me, the person who's standing in front of it? We also were curious about how embodiment of the agent would impact this. This comes on the heels of a very long history of HRI and human agent interaction, exploring how different embodiments and the various cues that different embodiments afford influence social perceptions and trust and other outcomes. So here we had participants come into the lab, which in this case was an office, and solve a word puzzle by finding tags that were scattered around the room. And these tags that were scattered around the room were either symbols, which would help them find the answer to the puzzle, or they were decoys. And participants were told that the decoys would eventually run out and set off an alarm. We didn't actually have an alarm, but we gave that part of the story to give people incentive to find the symbols and to do so quickly, and to ask for help from the agents rather than not interacting with it at all in order to help move their progress along. They were told that they were in somebody else's office. This was a fictional person who worked in the space. The participants weren't told anything about that person's relationship to the agent or about their fictionalized relationship to them, the participant. And they could, of course, ask for help from this agent. And we varied the kind of help that this agent gave. So it either gave mostly helpful information, which would direct participants toward the symbols, or mostly hindering information, which would direct them toward the decoys. And like I mentioned before, we varied its embodiment too. So it was sometimes embodied in a robot, which had moving eyes and could pan and tilt, sometimes in a virtual embodiment, which was just moving eyes, and sometimes in a pair of speakers where its only cue was verbal, nothing visual. So we got an overall self-report index of task experience. We didn't find any differences between any of the embodiment conditions. What we did find was an impact of quality of information. So unsurprisingly, when the agent was helpful, people reported having a better experience regardless of its embodiment. We also asked people about the agent's goal, and they were split on whether they thought it intended to help them or hinder their progress in solving the puzzle. So some people thought that it would help and interact with anybody who needed to talk to it. Some thought it was there to aid the primary user and that they were not being helped because they were unauthorized. Some people thought that it wasn't smart enough to know whether it was directing them to symbols or decoys. Some people even suggested that it was trying to gain their trust, perhaps deceptively. So as you can see, there are a variety of comments that came up organically about intent, whether mistakes came from intelligence or came from being affiliated with somebody else. And that's really what we were curious to see, was how that would play out. And these responses about helping and hindering only sometimes lined up with the actual helping or hindering condition. So 63% of the responses matched our manipulation, and the rest of them didn't. So what we learned here was that quality of information that an agent provides, it can impact perceptions of it, regardless of how it's embodied. And that affiliation with an implied absent user can open up questions about the agent's intent and its loyalty, and as well as user authorization, agent awareness, intelligence, complex social constructs like that. So the work overall that we've done so far informs our understanding of what's going on when we consider agent identities as something that can influence these arrows that connect entities like individuals, embodiments, and services. And I'll just wrap up by pointing out some of the ways in which we've figured out so far that we can leverage agent identities. We can design them to serve as interfaces to multiple embodiments and services when appropriate. We can design them to be cognizant of interpersonal context. And we can design them to behave in ways that are socially appropriate and match people's individual values and preferences, therefore giving people the opportunity to choose the way they want to interact with a robot that may or may not be assigned an identity. So I'm excited to dive more into some of the relationships in this diagram that we haven't explored yet for the rest of my PhD and beyond, and looking forward to hearing your thoughts on this work as well. So thank you so much.
Thank you so much, Samantha. This was really, really interesting. I would like to invite the audience now for any questions. The Q&A session starts now. So if you have any question, you can unmute yourself. You can raise your hand. You can also write on the chat and I'll read it for you. I can start out with a question. I have several ones that I have here, but so you talk about agent re-embodiments, and I was wondering how different it is for you of the term migration, agent migration, and if you could talk a little bit about how you think about these two different concepts in the field of robotics.
Yeah, that is a really great question. I'll preface this answer by mentioning that I think this is just my current understanding of it, but there's been a lot of work on agent migration, looking at what's actually communicated and what people are given the impression is actually passed back and forth between one body to another. I usually consider re-embodiment to be more about just the perception that the user gets of where the agent is embodied. So the concept of migration, I think migration is sort of more a data-centric word. Embodiment kind of reflects the bigger picture. So I'm not really sure if you would necessarily talk about co-embodying agents in the sense of migration in quite the same way, because there the focus on embodiment is on the actual robot that might have multiple agents in it. And if what you're trying to do is give the user a sense that an identity has moved, it doesn't necessarily even matter what data has migrated. It sort of matters more what type of front end things that can be communicated to the user have migrated. So I think they can be used, sort of interchangeably depending on the context, but that's the way that I differentiate. And I think re-embodiment focuses somewhat more on context and embodiment than on data.
That's a great answer. Actually, I never thought about it this way. Migration for me, I really like the concept of having a robot at home, and then I go to work and I use the robot on my smartwatch, and then I return and the robot knows the same things that I did with my smartwatch. But I guess that's very data centric, as you were saying. Yeah, that makes a lot of sense. Anyone has more questions for Samantha? Otherwise, I'll ask one more. So there was a study, I think the last one that you mentioned, where you compared a robot with a speaker and another version. And I was wondering, so the speaker only served as the voice part. And I was wondering if the participants of your study mentioned anything about considering speakers like Siri as well as a robot, and if you yourself consider them as robots. And if we just look at the speakers, not even at Siri, would then earphones could be considered a robot?
Yeah, I think in this study and in a lot of our studies, we actually, just because of the nature of the type of work that we do, we get a lot of people raising these questions about, do they consider something that's an embodiment but not actuated to be a robot? Sometimes we start interviewing people and they first have this thought, having not had it before, and that's also really interesting for us to see. So in this particular study, the task was deliberately really visual and embodied. And so in order to solve the task, you had to physically move around the room to find the pieces of the puzzle. And I would have to go back and check, but I don't remember a ton of people commenting on their thoughts on the speaker being a robot. And I think that actually had a lot to do here with the fact that you might need more visual and more embodied cues to help someone understand a more embodied task, even if the robot isn't actually using the fact that it's the robot to do the task. So I thought that was a particularly interesting distinction. The difference between having somebody direct their gaze towards something that they're asking you to go interact with, as the robot could do, versus just saying, look near this landmark. I think that played a really big role in this particular study. So that raised a question in my mind of, how the different types of modalities that people are using influence whether or not they consider different embodiments to actually be robots, and whether or not that matters, even if the embodiment, should it be a robot, isn't using its physical capabilities at that time.
Very cool. Yeah. Anyone else has questions? Sylvia, yes.
Yes, so my question relates with explainability, because I've done some work on embodied explainable agents. So I'm wondering if you thought about using explainability as a mean to explain what are the capabilities of the different embodiments, and if explaining how they work could let people in some way exploit more what they are able to do. I don't know if this is a clear question.
Yeah, so are you asking about explaining
the
decision making?
Decision making, yes. I did this in this way because I don't know, I have a harm for doing that, or I did this in this way because, and using that would give cues to the person about the capabilities, and in some way also maybe helping the transition among embodies. No.
Yeah. I like that question a lot, with the exception of the failure study, where we probed a little bit at different explanations of failure. We haven't really looked a lot at that intersection, but that's definitely something I'm interested in, especially if you're looking at the interaction of different forms of explanation and embodiment when you introduce this more complex setting of multiple embodiments, perhaps
Yes.
only having certain ways that they can explain decision-making and failure. So we sort of tapped into it a little bit in that we thought a lot about how we wanted to explain the failure and the recovery and the study with the vector robots going up the ramp.
Yes.
But we didn't actually manipulate that. So I'm curious about that too.
But in some way you did, because when you have the robots that close their eyes and put himself, like it's a kind of non-verbal behavior that explain certain things about the robot itself. So that's why I was wondering if you explicitly had like a look at this or not, like if you consider that as a way.
And that whole study could really be viewed as different explanation strategies too, because what's physically happening isn't changing at all. It's just what the system communicates, both visually and visually.
Yes. Just say you frame it from another point of view. So I found it really interesting and in line with this topic.
Yeah.
Anyone has more questions? I was wondering, Samantha, given the extensive work on re-embodiment and maybe even the conversation now with Sylvia, where do you see this work in the future? And do you feel that it would be easy for computer scientists to grab some of the principles that you derived from your work and to make it happen in actual long-term interactions, for example, in the robots of the future?
So I think there are a couple things, like we weren't sure when we started this work if people would ever take to this concept, because there's been work on this concept for a long time, and there was sort of a pause the last 10 years or so, and then it picked back up again recently, not just with our work, but in a few different labs like at MIT as well. And we weren't sure at the beginning if this would be even, seen as something that could be useful or comforting or give people a better sense of how to interact with the robot. Now we have a few studies that suggest that one of the main things that people do take from the same presence is that a sense of familiarity can be comforting, or a sense of familiarity can give people more assurance that their data is being used the way that they expect for it to. So I think one thing, you mentioned long-term interactions. I think really prioritizing, first figuring out, if a particular context that a computer scientist is working in needs a sense of identity, or a roboticist, I should say. If it does, really prioritizing that sense of familiarity could be really important. So multiple, for example, multiple interfaces within somebody's home that are all intelligent in some way and helping to provide that person care, like maybe for an older adult who's aging at home. The sense of familiarity across those devices in terms of a singular identity could be really important there, because it's really important to have comfort in that context, and familiarity and transparency, those are all really important. Whereas in something like a service setting, like a department store, people were usually a little bit less concerned about comfort and familiarity and more concerned about just efficiency. So I think something that people can take from our work is really considering their context. The next step that I think is really needed, though, in actually implementing that is understanding what cues, so to speak, and what observables connote a sense of a singular identity. And that's going to vary by population and by context too. So once we have that, I think we'll have a really great toolkit for roboticists and computer science to use in first designing and then implementing the identities of their systems. But we're part way to that right now.
I'll just follow up with, you mentioned in one of the studies in the beginning that, you mentioned it briefly, so I wonder if you could elaborate a little bit more on this result that you had about service robots and the fact that more intelligence on the robot. So there was this dichotomy between lower jobs and higher jobs, and how that is perceived and contextualized within a robot. Could you elaborate a little bit more on that?
Yeah, so that study looked at a bunch of different re-embodiments from one job to another, where the differential between the jobs was deliberately very varied. So in some cases you would have a storyboard where an agent re-embodies from a receptionist to a dentist in the same dentist's office. And then in another, you would have a situation where an agent re-embodies from a boarding agent at an airport to a pilot. And there were a lot of thoughts about how the particular context and that, in particular, the domain of service influences whether or not people can have confidence in this notion of like status and prestige and expertise. So when, in general, when the storyboard connoted some sort of risk, these things just like skyrocketed. So people's concerns about status became so much more prominent and so much more tied to their thoughts about expertise when the scenario involved risk. Whereas when the scenario involved, you know, maybe something that was really important, but wasn't necessarily personal risk, like talking about your bill with an auto mechanic, which was related to one of the scenarios we had, people just were not as concerned about the expertise. So we started to see the sense that maybe this question about status and prestige, maybe those things are tied together, maybe they're not, but it comes out much more when there's a sense of potential perceived personal risk in the scenario. So we haven't really dived deeply into what differentiates those things and whether concerns about status actually do even matter when it's like a lower perceived risk scenario.
I really like that result. It kind of reminded me of Sarah Fox's work, who is at CMU as well, on, I think she had this work on how an AI would organize the work of workers, basically service workers, and how that would be perceived by them, especially when the organization of the AI was optimizing something that was not entirely how they saw the job. So it's again this prestige and how much do you know compared to a robot, and how that changes according to context, which I think it's interesting tying it back to your latest result on comfort, or the example you were giving of the elderly person, that in service context, comfort is not the ideal variable, the most important variable to be twitched. But there are really important complex variables actually that depend on each other that could make a huge difference if a robot interferes there or an AI. So I really like that context because it's so rich also. Yeah, thank you. Anyone else has a last question?
Today, everyone is shy. It's because of the picture that Patricia put at the beginning.
Of you? Okay, so I can, I'll just then wrap up the session. Let me share my slides for a moment. Okay. We would like to thank our sponsors, Animates and CMU, for making this possible, especially in terms of our infrastructure costs. I would first like to thank Samantha for being here today and for giving this very inspiring talk. I think more roboticists should be exposed to these thoughts to make the field even better and more human-centric. And for next session, we will have Professor Pratap Tokekar from the University of Maryland presenting near-Earth sensing with aerial, ground, and marine robots. So we are shifting gears to a different topic, still very interesting, and we hope to see you here on February 16th. Thank you so much for being here today.